All right, we're going to continue on with section 4.1. So if you have not watched the live lesson or weren't there for it, please make sure you do that before you watch this one. We're talking applications about some of these different things. So you need to know a little bit about converting back and forth between radians to degrees or degrees to radians before you do this. And we'll talk about why in a second. So we're going to talk about two of those things. We're going to talk about arc length. So length of an arc in a circle, and then an area of a sector. And so like an arc length, for example, if I've got a circle here and arc length, we're going to say, hey, if this is my center, we're going to say, what's this length? That's arc length. Area of a sector, we're going to talk about similar things. So what happens is if I have the same arc length, we're going to find the area from the center. It's everything in here. So that's that area. So we'll have those conversations. So here we go, arc length S. We use the variable S. Of a circle given a radius of r with a central angle. And here's the key part. Theta is in radians that we're talking about. There is another formula out there if it's in degrees, but we're going to just make sure it's in radians so we can just worry about having one. So if you see degrees, you immediately have to calculate it to radians. So a reminder about that, you have to multiply that. That means you need to take your degree measurement and multiply it by pi over 180 degrees like we talked about in the live lesson. So you can kind of see where this is, but this is the formula that we'll talk about. S equals r theta. So that's the big one. And so you can kind of see that. So S is this arc length here. R in this case is that radius, the distance from their center to your circle. And theta is this radian measurement. Okay, so it says find the arc length. So it wants us to find S. This is important. You're not just going to always find S. Sometimes you're going to find other ones. Given a central angle of 3 pi over 4, notice that is, you see a pi, so that means it is in radians. That's very helpful. So that gives me that's my theta. It says a radius right there of 5, which means we know that this is going to be our R value. So I've got everything I really need here, which makes it kind of nice. So I've got S equals R and then theta, and I'm going to plug in what I know. Well, right now I don't know what S is, so I'm going to leave that as S. R we said is going to be a 5. And then theta, it is in radian measurement, which is good. So that's 3 pi over 4. So I just need to go to my calculator and literally type in 5 and then times 3 pi over 4. So 5, and then I'm going to multiply that times, and then I'll do a division here. So I'm going to do 3. You can find pi, or if you just type in pi, it'll do that for you. So 3 pi over 4, and you get 11.78. 11.78. In this case, we talked about how that was centimeters. So then this is also going to be centimeters. So that length of that arc that we're finding, so we have a circle. It's basically saying that the length, wherever my center is here, it's saying that the length of that arc right there is 11.78 centimeters. Okay, find the radius given the arc length is 44 and the central angle is 35. So a couple things. This gives us this find the radius. So that means I'm going to have to find what R is. It gives me my arc length is 44. It also gives me 35 degrees, but remember that's not theta. So if I'm going to calculate what theta is, I've got to take that 35 degrees and I have to multiply it times pi over 180 degrees, which is why I said this is where you're going to have to make sure that you've already watched the video from before, otherwise it's not going to make sense. These degrees are going to cancel out there, which is what I was hoping for. And then you can kind of simplify this in a number of ways. If you leave it like this and multiply across, because that's really 35 over 1. So then this would give you 35 pi over 180. And then you can reduce that and divide them both by whatever you want to divide them by. So like they're both even. So if you want to divide 35 by 7, 180 by 7, you get 7 over 36. So you can end up getting here 7 pi over 36. So then at that point, that's your theta. So now I have my theta. And some people say, well, can I just leave it as 35 pi over 180? That's fine for your calculation. Some people say, well, can I have a decimal? As long as you round out enough decimals, you'd probably be okay. So then this gives me S equals R and then theta. So plug in what we know. Well, we know S is 44. So notice that that's going to go here. We don't know what R is because it told me to find the radius at the very beginning. And we know that theta is 7 pi over 36. So in order to solve this, I need to say, okay, well, R is being multiplied right there is being multiplied by that fraction. So divide both sides by that fraction to both sides. So I need to do this whole thing there. I need to do 44 divided by 7 pi over 36. So 44 divided by, I need another division there, 7 pi and then over 36. So you kind of have to write it like that. So sometimes people do want to get that decimal, and that's fine. You can, and then do 44 divided by that decimal. This gives me 72.03. So 72.03. Very good. 72.03. And then this gives me, just didn't give me any measurement up here. So if you look, it just says 44. So I'll leave it like that. So my radius is that many units, 72.03. Okay, next one, area of a sector. So I kind of drew you a picture of what that looked like too. So it's, this is the arc length given your radian measurement. So this is saying, look at this whole area here. Almost kind of looks like a, like a baseball diamond in a way. And you could certainly calculate the area of the dirt in the baseball diamond if you wanted to do that. So, but here's the main thing. This is just kind of giving you exactly where it's found, but this is what we're looking for. So definitely you want that one. So 1/2 r squared theta, this is again saying that theta is in radians. So there's another one out there that if it's not in radians, if it's in degrees, you would use this. Not that you can't use that, but we're going to use this one because it's just consistent. So we don't have two different ones. So 1/2 r squared theta. Okay, find the area of the sector of the following. And so we can kind of do the same thing that we've basically done before. So what do we know? What do we not know? Sometimes that's really helpful for people to be able to figure it out. So here's what we know. It gives us this radius. So R. So R in this case is going to be 6. Now it gives me 75 as an angle, but remember that's not theta. So to find theta, I'm going to have to take that 75 and I'm going to have to multiply it by pi over 180 degrees. And again, this works out that these cancel. And let's say, for example, you're like, well, you said I don't have to simplify. Can I just leave this as my theta? Can I just leave that as 75, pi over 180 degrees and not reduce? You can do that. There are going to be problems where it's going to have you simplify it and reduce it into some basic ones. So you're going to have to know how to do that and just say what's common with both of these. But yeah, you can leave it like that. So again, my formula is the area is 1/2 r squared and then theta. So to find my area, the two things you need to know are r and theta. Well, I have my r right there. I do have my theta here. So my area would be 1/2. R in this case we said is 6, so it's 6 squared. And then theta would be 75 pi over 180. Okay, so now I need to type that all in. So 1/2, and then times, and then we said it was 6 squared, and then times, and again my fraction over here, we said that was 75 pi over 180. So 75 and then pi over 180. And so then typing that all in, that gives me 23.56. So 23.56. Look for any units. Other than degrees here, this doesn't tell me 6 meters or 6 inches or 6 centimeters, so we can leave this and just say that this is how many units they are. So just using the formulas here. What do you know? What do you not know? What are you looking for? So notice that here I didn't have to solve this one. If I go back to this one, I could plug it in and just get my answer. This one, though, I had to solve for. So you have to be kind of careful with what you have. So what do you need and what are you finding and all those things. Okay, sprinkler on the golf course. Fairway sprays water over a distance of 70 feet. So right here, here's a sprinkler. And saying here, that's 70. And rotates at an angle of 120 degrees. So it's kind of going through here. Still this, that would still be 70. And saying that's 120 degrees. Find the area of the ferry watered. So it wants to know what the area of the sector is. So, like we already said before, area of a sector, that's going to be 1/2 r squared and then theta. So, what do I need to know? Well, I need to know in this case that what my r is. Well, my r, that's this length. That's at 70. Okay, so what's theta? Well, theta, that's at 120. We have to use that to find theta, as we just talked about. I get 120, and I times that by pi over 180. And again, if you want to leave theta as 120 pi over 180, you can. We can also simplify that. So you can kind of take those different things and say, okay, well, they're divided by 10, they're divided by, 12, they're divided by 60, any of those different things that you want to kind of do, you can simplify that if you want to. Either way, in this case, you're going to get 2/3. So this is really 2 pi over 3. So I'm going to use that. Now, again, that's the last example. If you use this one, that's fine too. So to find the area, I get 1/2. That would be 70 squared. And then I get 2 pi over 3. And I'll tell you how much that fairway was watered. So same thing, I can change out some numbers here. That would be 70. Clear this out. And so that's a 2 pi. And then down here, that's 3. So still checking, making sure we have 1/2 70 squared 2 pi over 3. So 1/2 70 squared 2 pi over 3. And so you get that 5,131.27. So make sure I wrote that down right. And so 5131 and then 27. So 5131 and then 27. In this case, this is feet squared since we're talking area. So that's what your area would be. So that would be my final answer. So that's where these are used.